from home science to rocket science, from transporting on cycle and truck to transporting in carrier, from launching behind a church to launching in your space center, from zero to infinity. Good morning everyone. Today myself Rishil Shah and we the students of Rohini House are here to deliver a presentation on history of ISRO, pioneering India's space exploration. So these are our team members: Moksha from class 8, Shiza from class 9, myself Rishil Shah from class 10A, Hitanshu Gohil from class 10B and Akash from class 11. Indian Space Research Organization or ISRO is our own space agency. It was founded in 1969 and is now known for its significant achievement in space. But why do we need an ISRO? Because there are 3 and more advantages which ISRO grants you, that are technological advancement, economic benefits, national security, etc.
Dr. Vikram Sarabhai. Dr. Vikram Sarabhai was an Indian scientist who was also regarded as the father of Indian space research. He has established Indian Space Research Organization, which is also known as ISRO. In Gujarat, the Indian National Committee or Space Research, which was established in 1962, and it was set up by the Dr. Vikram Sarabhai and the Indian government. Then, in 1969, ISRO was formed. India's first satellite. As we all know that India's first satellite is Aryabhat satellite. It was launched on 19 April 1975. Named after the prominent Indian astronomer Aryabhatta. It enters the Earth's atmosphere on 11th February 1992.
The satellite launch vehicle. It was initiated by ISRO. And India's first effort to develop indigenous launch vehicle. SLV was developed to place small satellites in Earth orbit. The primary goal of SSV program was to develop a vehicle that could place small satellites in Earth orbit. The height of SLV is 22.7. The lift of weight means the weight of SLV is 17 tons. The propulsion is all solid. Payload mass means it could travel with payload mass of 40 kg. Orbit means till where SLV can reach is low Earth orbit. Augmented Satellite Launch Vehicle (ASLV) program. It is an upgraded version of SLV and extension of efforts to develop an indigenous vehicle using technology building on the foundation of SLV. The SLV was designed to increase the payload capacity as compared to SLV. It can place small to medium payload in low Earth orbit. The height of ASLV is 23.5 meters. The lift of weight is 39 tons. Propulsion is all solid. Payload mass of ASLV is 150 kg. Orbit is low Earth.
PSLV, the work of PSLV, the Polar Satellite Launch Vehicle, is one of the most important and dependable rockets of ISRO. Its development and success is essential in establishing India's reputation in the global space industry. PSLV had its first flight on September 20, 1994. It was designed because it has so many uses and it is considered as the cheapest rocket in the world. The lower part is engine and it used solid fuel. In the first stage, it also used solid fuel. Second stage, it used liquid fuel. Third stage, used solid fuel. And fourth stage used liquid fuel. And it is a place for satellite. PSLV missions. PSLV C-37. So, PSLV C-37 has set world record by launching 104 satellites in a single mission on 15 February 2017. Chandrayaan-1. PSLV C-11 was used to launch India's first lunar probe. On 22 October 2008, Mangalyaan, Mars Orbiter Mission. PSLV 25 launched India's first interplanetary mission to Mars on November 5, 2013. It was India's first mission to reach Mars orbit on its first attempt.
The GSLV satellite is a key satellite developed by the Indian Space Research Organization. It was launched on 18 April 2001. The mission was to take GS-81 satellite into the orbit, but the satellite could not be sent to the orbit due to the failure of the primary upper stage. Variants GSLV Mk1 and Mk2. These variants use Indian developed cryogenic upper stage and are capable of taking weight up to 2.5 tons. GSLV Mk3. This is the most powerful variant and is able to carry weight more than 4 tons. And GSLV Mk3 is sometimes referred to as LVM3. Chandrayaan 1 is the first mission taken by the Indian Space Research Organization to the moon. It revolved around the moon about 100 kilometers away from the lunar orbit. Mars orbital mission. Mars orbital mission is also known as Mission Mangal. It was launched on the November 5, 2013. The mission aimed for the study for the Mars. It is the lowest cost mission to the Mars.
Chandrayaan 2. So, Chandrayaan 2 was India's second lunar exploration mission. It followed the success of Chandrayaan 1. Chandrayaan 1, which found water molecules on the moon's surface. So, Chandrayaan 2 was launched on July 22, 2019, and it has an orbiter, lander, and a rover. Orbiter was successful, but lander and rover failed. Chandrayaan 3, it was ISRO's third moon mission, and it followed the success of Chandrayaan 2. It focused on lander and rover, and it relied on Chandrayaan 2's orbiter. Lander. They focused on lander so they can have a soft landing on moon's surface, and rover to explore the lunar surface. Its mission objectives were to achieve a soft landing and to explore the moon's surface and to technology demonstration so that in future missions they can know more about it.
Our next mission was Aditya L1. Aditya L1 was India's first mission to explore about Sun. It was launched to explore about Sun's outermost layer, chromosphere, including coronal heat. It was launched to understand more about solar dynamics and the impact on Earth's atmosphere. It was launched on 2nd September 2022, and the satellite and the rocket in which this satellite was launched is Polar Satellite Launch Vehicle C-7. Do you know why India gained level in space mission? Because of our indigenous technology. India has developed many indigenous technology over the years. As we see, the first technology is cryogenic technology. It means anything passed through it, it becomes cold, and it is present in propulsion module. So, to do not increase the level of heat.
ISRO's contribution in research, scientific mission, Mangalyaan. India's first interplanetary mission will provide valuable data on Mars atmosphere, surface and mineralogy. Then Chandrayaan mission. Chandrayaan-1 has groundbreaking discoveries of water molecules on the moon, and Chandrayaan-2 has been sending detailed data about the lunar surface and the atmosphere. Space-based observatories. AstroSat, India's first dedicated multi-wavelength space observatory, launched in 2015. And Aditya L1. These missions aim to study the sun and its outer layer. Satellite launches for different countries. ISRO. PSLV C-37. On February 11, 2017, it has set a world record by launching 104 satellites in a single mission. Commercial launch services. United States, launching satellite for NASA and private companies. France, launching the Spot satellite series for Earth's observation. Germany, launching the GBIM and other missions. Israel, launching the Venus satellite. And Singapore, launching various satellites for communication and Earth's observation. There are two notable missions, Cartosat 2 series and SkySat 1.
International partnership. ISRO has collaborated with many other space agencies around the world. And some of them are NASA. Collaborations include the Chandrayaan-1 mission, which moon mineralogy mapper was of USA was used in it. ESA, European Space Agency. ISRO has launched many rockets for ESA. Roscosmos. ISRO's and Russia's space agency's friendship is an example of friendship all over the world. Earlier, Russia was used to send their rockets for launching satellite into Earth's atmosphere, and now we are giving them PSLV and GSLV for their launch. So, I would like to end the presentation by saying a quote by APJ Abdul Kalam: "Be active, take on responsibility, work on the things you believe in. But if you do not, you are surrendering your fate to others."